Okay, good day, guys. Thank you so much for subscribing to our YouTube channel. Today we have a very interesting integral to tackle. Don't worry, it's very simple. The integral here is we have to evaluate the integral from minus infinity to positive infinity of sine of x all over x with respect to x. And this integral is called the Dirichlet integral. Now, we have 5 solution methods to use to solve this one problem. The first one is the Feynman streak, which everybody is aware of it. This method was introduced by the American theoretical physicist Richard Feynman. And we have method of direct Laplace transform, as we all know, to just transform the integral into a double integration using the transforming into the t wall. And the next we have contour integration, which is complex analysis. And we have another brilliant method, which is the MAZ identity. And we have the last, which is my favorite. This is the LOBACHEVSKY formula. This method was introduced by the Russian mathematician Nikolai LOBACHEVSKY. Guys, we are going to solve this question using the last 2 approaches. That is the MAZ identity and the LOBACHEVSKY formula. Join me, let's go. So hello guys, I'm very sorry the device we were using to record, it went out of storage. So now I solved the question and let me explain the solution carefully. So our question and the first method is the MAZ identity. So let's visit the MAZ identity. The MAZ identity states the integral from 0 to infinity of f of x times g of x dx is equals to the integral from 0 to infinity of the Laplace transform of f of x times the inverse Laplace transform of g of x ds, or in the s word. That's why you see the subscript s and the subscript s. Now we also have to know that our integral is not from 0 to infinity, but rather from minus infinity to positive infinity. So what can we do? Now we have to remind ourselves that to the blue note that the integral from minus a to positive a of f of x dx is equals to 2 times the integral from 0 to a of f of x dx if f of x is an even function, and it is equals to 0 if f of x is an odd function. Now if we look at sine of x over x, let's plug in minus x. If we plug in minus x, we have minus f of x is equal to sine of minus x over minus x. Now sine of minus x is equals to minus sine of x, and in the denominator we just have minus x. So you notice that the 2 minus signs cancel out, so we just have sine of x all over x, clearly stating that our integral is an even function. So it will now be the integral from minus infinity to infinity of sine of x over x dx is equals to twice the integral from 0 to infinity of sine of x over x dx. Now, applying the MAZ identity, we can let f of x to equal sine of x in the blue, because sine of x we can find the Laplace transform of sine of x, and we'll let g of x equals to 1 over x, because we can find the inverse Laplace transform of g of x. So our integral r is equal to 2 times the integral from 0 to infinity of the Laplace transform of sine of x times the inverse Laplace transform of 1 over x ds. Now if you find the Laplace transform of sine of x, we have 1 over s squared plus 1. It got transformed to the s word, and the inverse Laplace transform of 1 over x is just equals to what? 1, or with respect to s. So this is just equal to 2 times the integral from 0 to infinity of 1 over s squared plus 1 ds. Now when we integrate 1 over s squared plus 1 with respect to s, we just have the two standing out, we have the tan inverse of s, and we evaluate from 0 to infinity. It means that we have to plug the upper bound first, which is infinitive, and then minus the lower bound, which is 0. So the tangent inverse of infinitive is just pi over 2 minus the tangent inverse of 0 is 0. So we just have 2 times pi over 2 minus 0. Pi over 2 minus 0 is just pi over 2. 2 times pi over 2 is just equal to pi. So our integral from minus infinity to positive infinity of sine of x over x dx is equals to pi. So this is the solution using the MAZ identity. Now let's look at the next solution using the LOBACHEVSKY formula. LOBACHEVSKY was a Russian mathematician. This method is so unique. Let's watch it. Please do us a favor, subscribe to our YouTube channel, follow us on Facebook, on Instagram, and on TikTok. Lastly, if you have any of the methods listed above that you want us to use in our next video, write it in the comment section and we will do that. If you have math and physics question, drop it in the comment section. We will use it in another video. Let's look at the last method we decide to use today, which is the LOBACHEVSKY's formula. Let's visit the condition given. Now note, if f of minus x is equals to f of x, that is f of x must be an even function and f of x must be periodic. This is why you see f of x plus or minus n pi should also be equals to f of x. So if the two condition holds, then the integral from 0 to infinity of sine of x over x times f of x dx is just equals to the integral from 0 to pi over 2 of f of x dx. If you wish that we prove these theorems or these formulas, state it in the comment section and we're going to make a video with the proof of the LOBACHEVSKY integration formula. And the second condition here is f of x, if it is an odd function and periodic, this is what we use. That is, if f of x plus or minus pi is equals to minus f of x, and f of x plus or minus n pi is equals to minus 1 raised to the power n f of x, then the integral from 0 to infinity of the sine of x all over x times f of x dx is equals to the integral from 0 to pi over 2 times f of x times the cosine of x dx. Let's see how they solve our question. Now we already have the integral from minus infinity to positive infinity of sine of x over x dx being transformed from the first solution, being transformed to twice the integral from 0 to infinity of sine of x over x dx. How can we use LOBACHEVSKY formula? In this case, we identify our f of x to be equals to 1, because 1 is a constant. It does obey all of the following situations stated below. 1 is a constant. So in this case, we're going to transform 2 times the integral from 0 to infinity of sine of x all over x times 1 dx to just be equals to 2 times the integral from 0 to infinity of 1 dx, because 1 is equals to f of x. And when we integrate 1 is just like multiplying 1 by dx, it just dx. So 2 times the integral from 0 to pi over 2 of dx is just equal to 2 parentheses open x, and we evaluate from 0 to pi over 2. So it means that we have to plug in pi over 2 first and minus 0, because pi over 2 is the upper limit and 0 is the lower limit. So we keep the 2, we say pi over 2 minus 0, it just equals to what? Pi over 2. And when we multiply pi over 2 by 2, it just what? Pi. So therefore, fellow mathematician, we have proven that the Lobachevsky formula also solves our integral, which is the integral from negative infinity to infinity of sine of x dx is equals to what? Pi.